As Jeremy was saying, my name is Chris Davis. I work for a company named Amentum. About 8 or 9 months ago, we went through a name change. I've got a couple slides up here about my company because Jeremy kind of opened the door yesterday with his survey, asking if anybody was interested in a different job. Well, and who was hiring, and I was one of the ones who raised my hand. My company's hiring. We've got a couple of locations, but I'll talk about that in just a second. A little bit about me. I started with LabVIEW in 1999 as a summer intern with LabVIEW 5.1. Currently, I'm using like 2024 Q1 and plan to be using 2025 Q3. I use LabVIEW, I use Python, I do a lot of C and C++ programming as well. As Karsten pointed out, I also, at one time, not only did I learn Fortran when I was in college, but yeah, I still use it occasionally and still have to use it occasionally. It's not dead. Although Fortran 77 is about as far as I went in terms of learning new language there. And I've been working on Spanish. Have a 983-day Duolingo streak on Spanish with my wife. So I do have a wife. I've got a couple of kids. One of them's off the payroll. I have a dog as well. Enjoy 3D printing. Enjoy music and collecting Starbucks Been There cups. Collected a couple on this trip, and actually my last 3D printing thing was related to displaying those cups. At work, I do a lot of work with and do a lot of watching of home lab videos on YouTube. A lot of home labbers out there that if you haven't gotten into that particular hobby of watching those guys, they really can help you understand a lot of different IT concepts. I heard several people yesterday talk about, hey, I need to understand what IT does and how they work and why I might care about that. Take a look at some home labbers on YouTube, and there's quite a few out there that are really good at just explaining concepts and ones that you might care about in the work that we do. Fanatical about cable management, 3D printing at work, and starting to get into more and more CI/CD and cybersecurity work at work. But I do lead projects, both from the financial and from the technical standpoint, and then I do business development. And so a little bit about my company. Again, Jeremy kind of opened this up. If you are looking for a job, if you're here and you just happen to be looking for a job, my company's named Amentum. We are headquartered in Virginia. The group that I work for is out of the middle of Tennessee, a small town called Tullahoma. We also have offices in Detroit. We are actively looking for LabVIEW programmers and controls engineers. The group that I work for is called Advanced Solutions. We do a lot of interesting work for NASA, for the DoD, for the commercial markets, such as automotive. We're building wind tunnels. We're building test facilities. You'll see a NASA test facility up top there. You'll see a Formula One race car. We build wind tunnels for Formula One race car people, for NASCAR people. We operate those tunnels as well. This last slide was talking about 53,000 plus employees. We kind of joked about how could anybody work for a company that has more than 500 employees? I happen to work for a company that has more than 500 employees. The group that I work in has far smaller than that, but we do a lot of work across the country, and some of the benefits that come with that are getting to do some of these really interesting projects for the DoD, for the DOE, for NASA. We're all the time working with NASA and happen to be one of their larger commercial engineering services providers. Right, and so some of the work that my company, or my portion of the company does is, we'll often call it reach back, where we're contacted by operations groups that are looking for help accomplishing something their customer's looking for. So somebody like NASA or the DoD, they've got a project, they want to turn it over to their operations contract, they reach out to us and we help augment their staff to provide that work and then go away. We do a lot of, my particular part of the company does a lot of complex control and data acquisition systems, kind of got a system architect kind of view from here on the right-hand side, but all the time dealing with thousands to millions of aggregate samples per second. We use a back-end that's open source, so we have a back-end data streaming and data caching technology that's based on open source protocols and open source packages. Kind of our main piece of software that we sell to the world that's caught in a way anyway. It's called Testlate, and it's for large distributed control and data acquisition systems that we're oftentimes building for customers. That's why we made it. So on to what I'm here to talk about: time series databases and web-based front ends. Right? I threw up the definition from Wikipedia because I didn't know. I thought I'd do a quick little poll. Who has used or knows what a time series database is? Right? Anybody? Okay, a few hands, but not everybody. So a time series database, again, the definition is up here, but the main pieces that I like to talk to it about is kind of on the next slide. We know what relational databases are. Time series databases are something where we kind of flip that idea on its end. We don't have a heavily defined schema. We have a pretty lightweight schema, sometimes no schema whatsoever, right? So very little prior pre-planning is there. Time series databases are optimized to pull data and to take data in based on time, right? Time is the main index. The work that we do, or a lot of us do, right, are based on time-based data going by, needing to capture that, needing to be able to retrieve it later. So these time series databases are often optimized to retrieve data that's happened recently. Oftentimes they're optimized to automatically delete old, quote unquote, old data, where you get to define what old is. Right, so some of the ones I'll talk about today do just that. And then they're often optimized to communicate with IoT devices, right? It's some of their reason for being. IoT devices typically, they're gonna have a low-powered CPU, they're gonna have low memory accounts, so they're, in some cases fit in really well with some of the, like Compact Rio, some of the devices like Raspberry Pis and ESP32 microcontrollers. These time series databases are often optimized to talk with those kinds of devices. So those low cost, for instance, the Raspberry Pi Pico that was talked about yesterday, those lower cost devices that may not have a full OS, but they can send out curl requests, or they can send out and hit HTTP targets. Oftentimes that's what a time series database is optimized to communicate with. So it's optimized to maybe take in that data very quickly and get it recorded for that device, because that device really doesn't have any memory to spare. Whereas more of a relational database, again, those of us who went to school for like computer science, these are traditional databases like MySQL, Postgres, those larger ones that you're gonna deal with. You're gonna have a schema defined. They're gonna be optimized for data that doesn't really change very often. And I know, often is something we have to deal with, right? What I'm talking about often here is 10 times a second, 100 times a second. Time series databases are dealing with that. Relational databases are much more occasionally, right? They're HR records, they're sales records, they're metadata about information. So like I said, it provides ACID, which was an acronym I picked up last night, but atomicity, consistency, isolation, and durability. So just from a picture standpoint, right, this is actually from a different slideshow that I give as well, talking about the different data streaming, kind of the future of the industry that I see coming. So rather than data getting dumped into data files and then processed, time series databases excel when you're looking for data streaming, right? You're looking for data that's going on all the time. I'll show a few slides here later, but kind of one of the thoughts I had yesterday during our discussion, I think our first presentation, or first or second presentation from the Argonne National Labs, the kind of things where you're monitoring temperature of your reactors, you're monitoring your sodium temperatures, that you talked about all the time, right? Those are things that are happening all the time. You're maybe monitoring them once a second, or capturing data once a second, and needing to visualize that in a VR headset, which was really cool yesterday. It was really, really interesting. I enjoyed that. And so I like to think of this as like current value, kind of with some history, current value table data with history. That's what a time series database really excels at. So there's several time series databases out there on the market. I'm going to be talking about a couple here. Timescale is one that I've used all the time. Redis and InfluxDB are ones that I've boxed on here, but KDB is one that we've talked about and used. OpenTSDB, there's, again, You search out there, you're going to find a bunch. But I'm going to talk about timescale and Redis and Influx today, not to discourage you from looking at others, but those are the ones I'm going to talk about. I dropped a couple links on this slide for timescale, for Influx, and for Redis. Redis, you'll also find binary compatible versions with Valkey and Dragonfly DB, right? So these are all binary compatible versions of Redis with various different open source licenses that don't really make a whole lot of sense to go into today, but worth looking at the three of those. So how do I get data into a time series database now that I think maybe I want to use one, right? Oftentimes, again, we kind of talked about you can get that in there with HTTP commands, with curl commands that are pushing from the command line, with HTTP put requests or post requests. You can often get data that way into those systems. You can get there with structured TCP IP commands, for instance, with like Redis. That's an octopus of a tool that has got a lot of different capabilities, but it communicates over TCP, so it's very easy within LabVIEW to make a command string and send it out to a certain port on a TCP IP, and you have posted some data to Redis. Whether that be time series data, or you maybe post commands or responses. And then there's kind of the traditional OS layers such as ODBC. The database connection toolkit is based on ODBC. And that's, you're going to be able to talk to traditional databases, and we'll talk a little bit about that. That's a good way to talk to timescale. And then there's like specific communication libraries, such as libpg, right, for talking to Postgres or timescale. And those are going to be a little more platform dependent, but maybe a little more performant, right, when you're dealing with a specific database that you want to talk to. And so in terms of languages, like, again, I kind of talked about the database connection toolkit. That's an option within LabVIEW. Certainly sending simple TCP IP commands or sending HTTP post commands or put commands. You can do those all within LabVIEW. You can do those within C and C++, within Python, C#, Java, JavaScript. Those are all options, right, to get data into that. In fact, some of those are better than others, right? Python has got a lot of wood behind the arrow in terms of communicating with all of the timescale, all of the time series databases that I mentioned before. Of course, JavaScript does as well here. But it's not impossible to get data in there from other places. So one of the questions I often run into is, do these tools cost money, right? And because we're all conscious of money, even for a company who employs 55,000 people. Yeah, I'm conscious of how much these tools cost and what they're going to cost my customer, what they're going to cost me to play with and set up. Sometimes they'll cost money, right? Sometimes they won't, though, right? So if you're working in the cloud, if you're asking someone to provide those resources for you, eventually you're going to run into a cost with that. But usually they're free to try. All of these tools that all of these tools that I've boxed in here completely are definitely free to try and play with. And then eventually there'll be some sort of cost associated with that if you get your usage high enough, right? So if you're going to start using these for clients, we're going to deploy something. Sometimes our clients really don't have the IT bandwidth to deal with new things, right? So sometimes that cloud source or that cloud solution does make sense. Oftentimes I'm running them either because of client security requirements or our own knowledge and capabilities. We're running them what I call on-prem. Again, kind of a home lab term, but this is, I've got a machine I can put my hands on. I'm providing power and network to. That's usually a lower cost. You got to train yourself on how to deploy these things and set things up. This is where Linux and Docker are going to be your friend, which we've talked about a little bit already yesterday. But these tools are pretty easy to find. There's easy ways to find setup ways to do this within Linux and Docker. In fact, I've got a couple links in here towards the end of my slides. And then those, if you're doing that on-prem, you've kind of got low to zero ongoing costs, right? This is a machine. I've got to keep power to it. I've got to provide network to it. It's got to run up. It's got to stay up. It's got to have some operating system updates to it. But in general, it's going to be a black box I don't really have to mess with too often. So it's going to be fairly low maintenance and fairly easy to keep up and running. And so now I want to move on to kind of the second half of my discussion, while I've still got a few minutes left to go, is web-based clients, right? So I've got my data. I've decided on a time series database. I've decided how I'm going to push data into that. Maybe that's with HTTP requests. Maybe it's with raw TCP. Maybe it's through a specific library or through something like ODBC. I've decided I'm going to push data into that. How do I view it, right? Do I need to build a LabVIEW client that queries that database, or can I use something else? Jeremy and I were just talking about some of these web-based clients. In particular, I've got 3 up here, but the one I'm going to talk about the most is Grafana. And so I'm going to show some kind of slideshows from our internal dog fooding of Grafana that we've been running for years. So these are just some slideshow pictures of internal things that we've done with Grafana, right? So we've got an XY graph where we've charting temperature over a 24-hour period with data taken once a minute. We're showing an XY graph, but we've also got some stat charts where we're monitoring things like our 3D printer. The one on the right, if I had not taken it at 10 o'clock last night, would have one of those squares lit up to help us show, maybe from a flowchart standpoint, what time of day it is, right? We've talked to our customers about, you've got a big test facility. You're often prepping for another test, like a rocket launch or something like that. Wouldn't it be nice to know what portion of the prep process we're in from a flowchart standpoint? We've got these 5 things to do. Billy Bob's working on this one. Let's show that we're waiting on Billy Bob to finish his piece of work, and then we've got a 30-minute wait, and we've got this to go, and then we've got these decisions to make. We can show that in a flowchart that's dynamically generated based on information that's out in the world. Another XY graph, a table with some percentage, kind of a bar chart available. A few others. This happens to be, again, because this is a website, because it's a web page, I can show images, I can show movies right alongside, I can show IP camera data right alongside my XY graphs. A few others from Grafana's Playground and Grafana's Pictures that are available online. Some of these are a lot more interesting than the ones I've made, but really showing out what's available. If you're looking for other people who are using Grafana, you don't have to look any further than N.I. Their System Link tool, right? Their System Link, I think it's the System Link Enterprise piece, uses Grafana as its display package, right? They happen to use a different time series database in the back end. I think it's MongoDB, if I'm not right. Please correct me, but they're using, again, another time series database in the back end to store their data, but they're using Grafana as their display tool for that. Here's, for instance, a canvas display of data from a solar panel. And on the web, this is animated and showing you essentially data. You can start to see some data next to the solar panels, next to the power meter, next to the batteries. So you can create these custom images and create these custom UIs of your data while it's coming in live. Another piece of this, and this is kind of where did Jeremy go? Right? This is maybe what Jeremy would have benefited from his recent work, right? Grafana not only has that UI capability, but it allows you to build those dashboards. It has the ability to drop a visualization piece. I've got visualizations here on the right of this slide. And then one of the things I love about it, especially when you pair it with Timescale DB, it's got a SQL builder. It's got a SQL drop-in SQL editor, right? So you can say, I want to talk to this database. I want to pull this information. I want to pull it for the time frame that I've got up in the top of essentially like the last 24 hours, or maybe I've got a set time frame I want to pull this from and display this. I want to build a set of SQL queries. Maybe you know SQL really well, maybe your customers don't, right? That's what I usually run into, is I know SQL pretty well. I'm certainly not the world's best SQL programmer, but I know SQL well enough that I can build a pretty decent query, but these two tools paired together allow me to turn this over to my customers and not have a fear that they're going to run a Johnny drop table on me and make something go away from their data. As I finish up, I kind of want to talk about just my recommendations, again, tools to take a look at. I'm not up here for an hour. I'm finishing up here in just a couple of minutes. So Timescale, DB, and Grafana are the tools that I prefer and that I like to look at. Timescale DB because it's built on Postgres, a open source database that's been around for 35 plus years. It can essentially have timescale data or time series data in it alongside a relational database, and so it kind of marries the two together, allows you to really set those up. It's been around for 40 years as an open source project. It's got a lot of wood behind the arrow, a lot of setup information available online. And then Grafana has been around for about 10 years, and again, it's runs really well and connects to timescale really well. A lot of times all you need to look at for this stuff is going to be an old machine with a little bit of RAM, decent amount of RAM, a CPU, and some SSD storage. From a cybersecurity standpoint, these tools can be hardened very easily to work in a zero trust environment with RBAC or role-based authentication and control capabilities. And these tools, again, they help us build these complex data acquisition and control environments where we're streaming data, where we've got systems in multiple buildings, where we've got systems that are going on all the time. We've got managers and information that needs to be displayed about what's going on in building 1 versus building 2 versus building 3, spread across the lab. Now I'm going to be taking back from the Argonne Labs discussion we had yesterday, information about how we can display that in VR on top of, showing people what's going on. So I wanted to wrap up. I got a couple minutes for questions. I'll also be here, all day. If you've got questions or want to talk about some of the information I've got, please let me know. Yeah, go ahead. Sorry, yeah, you have to use the mic.
Can you talk a little bit about getting from LabVIEW into Timescale DB?
Sure. Yeah, getting data into Timescale DB from LabVIEW. Typically, from a Windows client, the easiest way to do that is through ODBC type connection. Maybe not the most performant, but there's the database connection toolkit that N.I. has out there available for both 32 and 64-bit. That's what I find probably the easiest way to get stuff in. If you're looking for alternative ways, there's also, I found it on VIPM last night, there was specifically for talking to Postgres, which is timescale underneath, or timescale is Postgres underneath the hood. There was a VIPM package that I saw on VIPM last night that would allow you to push data into Postgres only, right? That's going to be, but the beauty of it is it's going to be, it seemed to work both on RT and on the Windows and on the Mac side as well. So that was a couple options for getting data into timescale. Other questions? Yeah, Hunter, go ahead.
When you're using those tools, where do you find the bottlenecks are? When you're talking about high channel count or high data rate, is it in the getting it outside, or where are those bottlenecks in your process?
Yeah, the bottlenecks that we see most often are going to be getting data into the system when you've got obscenely large channel counts. Let's talk, right? Thousands of channels is not usually a problem. These systems are designed to handle thousands of interactions. Now, it may require you to scale up your CPU and the horsepower you're running this on, right? It may require that kind of scale up. So again, I may not be able to buy the $150 Dell PC that was on Amazon that's off lease 10 years ago. I may not be able to run this on that, but if I'm throwing a sufficient amount of horsepower and RAM at it, those problems can be solved. But the deadlines or the things that we run into usually are getting tons of data into it. And the way that we typically deal with that and the way that it kind of takes care of itself is that we've got clients that are distributing that information. They're already distributed. I don't have 10,000 channels in a single place pushing into this. I've got 1,000 channels here, 1,000 channels there pushing into that. So hopefully that answers your questions. My time is up. If I'm okay, I can take another question, or we need to stop. One more question. I think it was back in there, back in the corner.
Yeah, I'm just wondering if you could talk about how involved the installation and setup procedure is. Is it something that a manufacturing engineer could basically run with no IT knowledge quite easily, or is it more involved than that?
I won't say zero IT knowledge, but I'll maybe to answer your question, find me later and I'll show you kind of our we've got a couple PDFs that we use to train people on how to install in Docker, Grafana, and Timescale, right? Again, there's the links I had maybe there are officially supported by those companies, and they're not really that hard. Maybe half a dozen steps. Again, you have to understand Linux. You have to have some basic understanding of Docker, but these kind of walk you through that. There's tons of YouTube videos on how to do it too, and how to do it in a special way that, you know, some home labber thinks is the best or works best for their systems. But these tools, again, in my work hobby of looking at home labbers, these tools come up a lot because this is a set of tools that home labbers use to monitor their network infrastructure and their system health, and monitoring temperatures and network usage and CPU usage of virtual machines and systems like that, right? These are often found using that. Grafana itself was, when it was made about 10 years ago, was designed for data center monitoring, right? But it does a really darn good job of showing data from other things. All right, so my time's up. Again, I'll be around if you have questions. Please come find me. I'll be happy to talk about these subjects. I've also got a 7x7 coming up later today, not about this particular subject. But anyway, thank you guys very much.